Today I'm going to be teaching you on how to evaluate the limits of absolute value functions. So let's get started. So what is the limit of the absolute value function of x minus 3 as it approaches 3? So what we can do here is just direct substitution. So if we direct substitute this, 3 minus 3 is 0 and the absolute value of 0 is 0. So that is the value of the limit. So what if we have this problem? What if we have the limit as x approaches 0 of the function absolute value x over x? So this is going to be the limit doesn't exist. If we see this, if we have a absolute value function on the top, on the numerator, and the denominator is just x, which is going to be undefined if we plug in the 0. So to make sure that doesn't exist, we can just plug in numbers that is closer to 0. We can go from the right side or the left side. So the right side muna. So we're just going to approximate this. So let's just pick a number that is close to 0 but on the positive number line. So this is going to be 0.1. The absolute value of 0.1 is 0.1 divided by the 0.1. 0.1 divided by the 0.1 is just 1. Now let's move and calculate the limit as x approaches 0 from the left side or the left side of the number line. So let's pick a number that is really close to 0. So let's say 0.9. That is a good number, right? Or we can just extend it like 0.9. Or we can just plug in negative 0.1. So if we plug in negative 0.1, it is just going to be 0.1, 0.1, and if we plug in x, it's going to be negative there, and it's going to be negative 1. So if this happens, if we approached the limit from the left side and the right side, and it doesn't equal, the approximate value doesn't equal, so that basically means the limit really doesn't exist. It doesn't exist. So as you can see here, the limit from the left side and the right side is not equal. So the limit doesn't exist. Okay, now let's take a practice problem on how we will evaluate it from left side or right side. So let's say we have this limit. Limit as x approaches 5 from the right side of the absolute value x minus 5 divided by the x minus 5. So if we direct substitute this, like it's the only 5, we're just going to get 0 and then undefined. So we're just going to use the limit as x approaches 5 from the right side. So we're just going to pick a number that is closer to 5 but positive on the number line, to the right of the number line. 5.1 minus 5 is 0.1. 5.1 minus 5 is 0.1. The absolute value of 0.1 is 0.1 divided by 0.1. This is just basically 1. So that is it on how to get the number from the right side of the number line. So what if we have the limit as x approaches 4 from the left side? So the arrow, not the arrow, but the sign from the above the number, if it's just negative, meaning it is from the left side. If it's positive, and then it's from the right side of the number line. So let's just plug in a number that is close to 4 from the left of the number line. So 3.9 minus 4. So we will just get this. We got 0.1 here, negative 0.1, and then we will get negative 0.1 once again here. The absolute value of negative 0.1 is going to be 0.1, and we got this. So this limit is just negative 1 if we approaches 4 from the left side. Now let's take another example problem. Now we have the limit as x approaches 3 of the function x minus 3 x and then x minus 3. As I said earlier, if we have a absolute value function, this is going to be just those DNE, those not exist. But to make sure that it is really doesn't exist, we're just going to use approximation of values here. We're going to find out what is the limit as x approaches 3 from the left side and the right side. So that is basically what we're going to do. So 0.1 divided by 0.1 is 1. So if we approach the limit of x to 3 on the left side, they will not equal. But to make sure, we're just going to test it. So 2.9 minus 3. 2.9 minus 3 once again. So we will just get 0.01 on the top. I'm not using any calculator right now. This is going to be negative 0.1. So yeah, it's just going to be 0.1, not 0.01. So we will get this and this. The absolute value of negative is positive. So we'll get negative 1. Let me just put equals here. So there you go. So as we can see, it doesn't equal, meaning it does not exist. Now let's take this on the last problem. This is from my thumbnail. What is the limit as x approaches 1 of the function x squared minus 1 divided by the absolute value x minus 1? So here, if we plug it in directly, we use direct substitution, we will just get 0 as our denominator, meaning this function is undefined. The limit of this function is undefined from x to 1. So what we're going to do is just approximate it from the left side and the right side. So let's start with the right side first. So we're going to plug in a number that is closer to the 1, but on the right side of the number line. So what it is, let's just say 1.1. So if we're just going to plug in 1.1 here, 1, then 1.1 minus 1. So 1.1 squared, what is it? It is 0.21 minus 1 na siya. Agad na siya. So 0.21 minus divided by the 0.1 is going to be 2.1. So now let's try to the left side. So what is the limit as x approaches 1 from the left side of the function x squared minus 1 divided by the absolute value of x minus 1? So let's just pick a number that is closer to 1, but on the left side of the number line. So let's say 0.9. So we're just going to plug it here. 0.9 squared minus 1, then 0.9 minus 1. So 0.9 squared, what is it? So basically, we're just going to use our calculator because we cannot approximate it. So it's going to be 0.19 minus 1. I already have take the difference of that. And then on the bottom, what we will get here? We will just get 0.1. So using our calculator, but we still have absolute value function. I forgot it. So we will just basically get negative 1.9. So meaning this limit doesn't exist. So even though if the absolute value function is under, it still doesn't exist.